Hello everyone, this is question 14 on paper 1 from 2023 from Edexcel, and we've got a proof question. And this is one of those really nice proof questions that's basically like a GCSE question. So it says, prove using algebra that n add 1 all cubed minus n cubed is odd for all values of n. I tell you what, if I was sat in the exam and I saw that come up, I would be so happy. So all we've got to do here is literally just prove that we get an odd number when n is an even number and when n is odd. And then that's it done. The definition of an even number is 2 times something. So I've said let n equal 2 times m. Okay, so then we're just going to sub that into the expression. So n add 1 cubed minus n cubed is going to go to n gets replaced by 2m. So we have 2m add 1 cubed minus 2m. Now remember, a kind of like nice little shortcut for expanding a cubic is to use the binomial. Okay, so if you remember, well, what do I mean by that? Let me just quickly show you what I mean, because this is such a useful thing to know for the future. So if you've got a add b all cubed, rather than having to go to the length of doing the whole expansion by longhand, you can just use this pattern. So it's going to go to a cubed, add 3 lots of a squared b, add 3 lots of a b squared, add b cubed. And that is just such a nice little shortcut for expanding a triple bracket. Okay, and that's what I've done here. So my first term is 2m all cubed, then I've got 3 times 2m squared times 1, 3 times 2m times 1 squared, and then plus 1 cubed, minus the 8m cubed. So you collect like terms, the 8m's cancel there, and we get 3 times 4, so that's 12m squared, and 3 times 2, so 6m. Now I've just taken out a factor of 2 from the first 2 terms, and this is odd because we've got 2 times something add 1, so therefore odd. And that's perfectly fine. In the mark scheme, they've just done it slightly differently. They've factorized it a little bit further. They've taken out a factor of, they called it k, and they took out a factor of k, and they took out another factor of 3. So they wrote it in this form, where we've got even times by odd, and even times odd is even, and even add 1 is odd. But the mark scheme is quite clear that they will accept any sort of like valid form. So it's perfectly fine to write that one like that. So that's it done for even. So now let's consider odd. So the definition of an odd number is 2 times something add 1. So we're going to do the same process. We're going to replace the n with 2m for add 1. So n has been replaced by 2m add 1. There we go. Like so. Again, I'm just going to collect like terms. So 2m add 1 is 2m add 2. And then I'm going to use the binomial as I explained just previously. So the first term is going to be 2m cubed. Then we're going to have 3 times 2m squared times 2 to the 1, plus 3 times 2m to the 1 times 2 squared plus 2 cubed. So that's that one done. Same idea here. 2m cubed, 3 lots of 2m squared, 3 lots of 2m, and then 1. And then we just simplify everything. So we've got, just work out what all of those terms are. So 3 times 2m squared is going to be 3 times 4. So it's going to be, and then there's another 2 there. So that ends up as being 6 times by 4. So that's 24. This one is going to be 3 times by 4 times by 2. So it ends up as 24 as well, and so on. And then we collect like terms, and we end up with 12m squared plus 18m plus 5. Now, there's various ways you can deal with this. I've chosen to rewrite 5 as 4 add 1. So that's enabled me to write that this whole thing is 2 times something add 1, and therefore odd. Perfect. And then we've now proved that the expression is odd for all even numbers. We've proved that the expression is odd for all odd numbers. So therefore, by definition, it is odd for all n is a member of the set of natural numbers. I hope you found that was a real nice proof one, wasn't it? Nice 4 marks, especially towards the end of a paper. I hope you found that helpful, and I'll see you in the next video.